.NET. Just wanted to go through my experience with the OpenHFT in Java, that open source project that I was really liking in last few days. I've spent probably about 5 days with it, trying to figure it out. Kind of got ahead with it, and then when I started digging more into it, started just throwing weird exceptions, something to do with Maven objects and whatever. So I got to a point where I just kind of gave up on it, and I started kind of basically abandoning it among millions of other projects. One of the other big things that kind of scared me with it is there was one of the products, I guess, that was moving from 3 to 4, and there was a comment on the forum there where the person said that one of the functions was removed, that was open source, and then one of the team members from Chronicle Software said that they had moved that function into the commercial product. So basically, without any announcement, without any worry of impact on current systems that may be dependent upon that open source function, it now breaks it when you want to upgrade to the latest product. So as a result, these kind of changes are not future-proof. They're not backward compatible, and it can get kind of scary. It reminds me really a lot like, if you remember the TradeLink fiasco, where you're depending on a open source trading platform. And then he just decided to disable pretty well the whole thing before he came out with that Gleam product. So it's the same idea. I've seen it also happen with an open source Java product for trading. I can't remember the name. And then there was also Market Central was another one as well. So I really don't think that's probably the wise move. So as a result, I wanted to move into a combination of TBB and preferably Redis, and I had no problem getting the TBB compiling and built on my Mac. That's the Intel threading building blocks. That was not a problem. And then we moved into Redis and MongoDB. Redis is just poorly supported in the world of C++. I think I've gone on about that, so that didn't make it possible. And then there was MongoDB, which I've had running before, but they had this new MongoDB 3.11 C++ driver, and I think it worked up to a certain point with prior Mac OS El Capitan, but some of the core libraries got removed by Apple, and I guess whoever's maintaining the Mongo listed that as a bug, but they didn't upgrade the workarounds for that in the installation. So as you can imagine, that can be really frustrating. So that led me to my next choice, which I was a little hesitant on, is SQLite. So here we are in SQLite on my Xcode, the IDE in C++. So as far as I know, it can be as fast as Redis. The thing is that it's only in memory. It doesn't have the replication or the clustering over multiple machines. So I've always known about these limitations, but I just want to get this thing running on my Mac, compiling, in Xcode. So I managed to get something built, and I built upon one project solution file versus the next, all along here and here, and basically it took me a while, but I was able to do it, which is good. So I'm going to do a quick walkthrough of this with SQLite. So if I go into my SQLite, you can usually do the install with brew install, so that's not a problem. I just want to highlight the version. This is the latest version I can get, 3.14. That's all good. As I kind of work with more SQLite, it kind of grows on you like a piece of asbestos growing in the corner. So it kind of grows on you. But anyways, I've got the first function or the first source example here, and then I added this as well. So what I've done is basically if you come into the main function here, this is really more C than C++. But the nice thing is that it's part of the C++ standard library, so you don't have to worry about a lot of weird, installing, looking for a search path and all that. It can be kind of a pain. But let me just show you on another project here. So let me just see where, okay, this is what I want. So first thing that you need to be aware of in this one project is when you can by default call your SQLite 3 header file without the need of defining that in the search path, because it's automatically taken care of when you do the brew install. But what I have noticed is to define the library profile under the build properties equivalent in Visual Studio. What you'll find here is you need to define the location of the library for SQLite 3 as in here. So I did that, and it's going to be in here. You just do a search. So let's say you do SQLite, and you just pick off, I think this one or this one, and that's all you need to do for the compiler and the linker to find it within the project of defined by Xcode. So that seems to work okay. So let me take you back to the bigger project. So this is fairly simple code, to be honest. So I'm just going to start in the main function here. And what I've got here is you just define all your SQLite definitions. You do your typical open where the file is located. I guess you could say it's similar to what OpenHFT did, where it defined a local file as well, and then it's still in memory. So what I've done here, which is the new code, the nice thing about SQLite is very simple. So let's say in SQLite you want to set up a callback function here where if there's any changes in the database, your C code or C++ code will see that by setting up the callback methods. So that's what you have here. It's pretty cool. So if there's any changes in the in the database, you can define and customize these callback functions. So here we are involving a update, a commit, and a rollback. So you have full transactional, I can't remember what they call it in typical SQL land, transactional logging, I guess. But here are the functions that you can define. So here we have our update callback. I just kept it really easy, where it just prints out a statement saying your database has changed, your callback for the commit. So it will notify you that the database has changed. If there's a change and you want to make a commitment to that change, you can log that here. And if you want to roll it back by canceling it, you can do that as well and just do this, whatever. So you have full control of that, which is kind of good actually, in its own way. So going back to where we were in the main right here, we continue along. So in this case, what this code will do is it will do an insert into the database. So what's going to happen when it does that insert? It's going to call this callback update function and then print out these messages. We'll take a look at what's run in the code. So obviously we have to commit as well. So we do the insert step, finalize, and then commit. That's the transactional logging. And in here, if we decide not to proceed with a commit, we can then roll it back if we want it as well. So then once we do the insert, we can then do a simple query on employee, and that's it. Okay, and then you have to close out the connection. So that's pretty straightforward if you ask me. So when I run it, and we go through here, what we'll find here is that you know, when we do that insert, we are calling the commit, the callback function right here. As you can see, hook committed. I'm sorry, where is it? Right here. The database has changed, which is in the update callback function. Prints out the data, and then at the same time, once we commit, it will then also run the hook committed, as you can see here. And then if there was a rollback, we can do that too. And then I don't think we have a message for the insert. And then here, number of arguments, that's the selection, which is right here. So here's our selection, and it looks like we have another callback function for the selection, which is right here, and this is what it prints out, number of pages, and then blah blah blah. Okay, pretty simple stuff. So that's pretty well how the callback works within SQLite, which is actually pretty easy when you think about it. But in here, you can also basically commit the database, and then theoretically for trading purposes, this is right here. If we're going to do a commit to the database, we can launch some kind of algorithm, or so basically how I envision it is, let me just pull up my little document here. So essentially what we're going to do is, traditionally I use Java to push my Java into Redis, but what we're going to do is, because I can't really compile the Redis on this Mac, what I'm going to do is then push my Java data from IGFeed into SQLite. So all the data goes in there, right? So at the other end, which I just showed you, is the C++. So once there's a change in the Redis or in the SQLite, it will basically notify the C++ what I just showed you, and it will kick off a function of some kind, which is going to be pretty well my algo or set of algorithms. And this pretty well will be the algo. It's kind of like streaming, where I'll do a quick, like once I know a new data item has been inserted into the database or pushed into the database from the Java side, which is where my market data feed will be. Basically, from there, I'll have a SQLite in the C++, call that callback, that update callback, because now the database has changed or the table has changed. And then what we can do is we can start streaming and checking, let's say the 10 prior entries, or 100 or 1,000 or whatever I set, of whatever my look back would be, and then run an algorithm, do a calculation. If that calculation and the result of it triggers an exit, meaning a market exit, then what happens is we do basically an entry into them, or an exit out of the market. Okay, because basically what's going to happen here, there's two things. Okay, so we won't even get to this point until we know we're actually entering into the market. So So I'll repeat this just to make sure everyone's on board with this. Okay, so basically what's going to happen is if I have, let's say, a pair trade. Okay, cool. So let's say I have a pair trade and we're analyzing, just market conditions, and then all of a sudden we know that there's now a market entry or a condition for a market entry for going into the market with the pair. It could be for any asset, not just a pair of stocks or whatever. So once we know that, then we're going to kick off two processes. This one and this one. Just to make it easy for you. I mean, it's going to be doing more than this, but this is the architecture, very simple. There's two processes that get kicked off. We basically kick off the Java stream, which will start watching the markets for this particular set of assets. So let's say if we're dealing with GM and Ford, okay, as the shares, right? So now what we're going to do is we're going to tell the Java streamer in IKEA that I've shown before. We're now going to tell the Java streamer to start watching and adding GM and Ford to the Java stream listening process. So now it's going to start listening to the GM and Ford through the market data stream done in Java. I've shown that before. And then the second process that gets kicked off is this like equivalent of the C++ program built around SQLite, and basically it's now remember when these do get kicked off, there's basically a signal to enter into the market. So we have to at some point tell the system to enter into the market. So maybe there's a third process or something. I don't know yet. This could do it. The C++ could do it. But once we enter into the market, what needs to be done now is we're watching the market, and because that's getting now kicked off, we're now going to have Java, the IKEA push the market data into SQLite, and then once at the other end, we'll wait maybe, I don't know, a couple seconds or a minute or whatever, or keep reading in the C++, reading the SQLite table, and once we have 10, 100 or whatever rows for that database or table, we can then start following that data, that market data for that instrument of security. And then we can start running the algo, whatever the algo is. In my case, for the AT, it'd be the average true range. Very simple on that data from the queries that I just showed you, or a form of it. And then once, as the data is streamed into the SQLite, then we can basically use the algos or whatever set, if it's 10, 100, 1, 2 algos, and then certain conditions are met, then we can exit the market. Okay, so I'm hoping I made sense there, but with the function of the algos, this function that I'm referring to is really the callback function I just showed you. So I'll show you that in the code again here. Where am I? There we go. So what I'm referring to is right here, because now we know that the database has changed, the table has changed. This callback will then mean we have a new entry in the table for that market data instrument. So here we can then have the algo listener run its process of the number of rows that we want to use in the look back, do a calculation, yes, no. The market condition says yes, get out of the markets or exit the market, then we trigger an order. Okay, so I'm hoping that makes sense. Where's my, yeah, so here, yeah, I've already defined it. So yeah, so once we hit a certain number of conditions and then there's a signal from the algo, we can then exit the market. Right on. Okay, so that's pretty well it. The nice thing with SQLite, it is open source, and it does work on it does work on Mac, or I can build on Mac, which is good. And we don't have these crazy potential issues of when you use a framework like OpenHFT or another one where they could take away functionality, because SQLite is true open source, right? And it's in memory as well, and it should run. It's written in C, so it's stable and blah blah blah. So the key here is on your server. You will probably need to have it on a pretty big but fast drive, because SQLite, you can only run one instance of it. But the real benefit is if you can get a large hard drive with a lot of drive space. But the other key is to make sure that you have the ability with a lot of inline memory or RAM for that server, that whatever you choose. And I know there's a lot of servers that can go up to 1 terabyte, 2 terabytes in memory. So that works, because SQLite can work with that, no problem. Okay, so I'm going to shut up now. Hopefully you understand where I'm coming from and see the shift here that I'm making. Hopefully this will work out. Yeah, I kind of like the OpenHFT. It's just kind of sad to see that there's that risk of those sort of things happening with future functionality taken away in the future, or with all these exceptions. This is such a simple method once you understand how it works with the SQLite, and you understand with the Java, and then just feed it all into SQLite. This will definitely be pretty straightforward. So hopefully, once I get it complete, we'll be pretty happy with it. All right, I'll talk to you later.